Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of Tabby's star, the strangest object in the universe, and what it might be. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 2015, citizen scientists analyzing Kepler Space Telescope data noticed something extraordinary. A star 470 light-years away was dimming by up to 22%, far more than any planet could cause, in irregular, non-repeating patterns that matched no known natural phenomenon. The dips varied in depth and duration. They came without warning and without predictable interval. Nothing in the catalogue of stellar behaviour produced a pattern like this. For a brief, remarkable period, the world's leading astronomers seriously and publicly discussed whether the dimming might be caused by a Dyson swarm, a megastructure built by an advanced alien civilization to harvest energy from its star. The hypothesis was not fringe. It appeared in a peer-reviewed paper co-authored by a tenured Penn State professor. Crowdfunding campaigns raised hundreds of thousands of dollars to observe the star continuously. What was eventually found was almost as strange as the alien hypothesis, and the long-term dimming still does not have a complete explanation. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space is not quiet. The universe is filled with electromagnetic signals, from the cosmic microwave background radiation left over from the Big Bang to the steady roar of stellar activity at every wavelength of the electromagnetic spectrum. Against this noise, radio astronomers look for something specific, signals that are narrowband, repeating, and structured, the signatures of intelligence rather than nature. Natural processes tend to produce broadband emissions spread across many frequencies. A narrowband signal at a single precise frequency suggests something deliberately tuned, and deliberate tuning implies a tuner. The search for such signals has been ongoing since 1960, when Frank Drake pointed a radio telescope at two nearby stars and listened. In the 60-plus years since, the instrumentation has grown enormously in sensitivity, and the sky survey coverage has expanded from a handful of stars to millions. The verdict so far is ambiguous. No confirmed, repeating signal from an extraterrestrial intelligence has been received, but several anomalous signals have been detected, investigated, and not definitively explained, including at least one that, had it been received today, would meet every criterion the scientific community had previously agreed would constitute first contact. The silence of the cosmos is not total. It is merely inscrutable. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns, in science, demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding Tabby's star, the strangest object in the universe, and what it might be is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Kick 8,462,852, designated Tabby's star after citizen scientist Tabitha Boyajian of Louisiana State University, who led the analysis, was identified through the Planet Hunters Citizen Science Project in 2015. It is an F-type main sequence star approximately 1.5 times the size of the Sun, located 470 light-years from Earth in the constellation Cygnus. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes, but as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern, but that is only the beginning. Researchers also discovered the Kepler Space Telescope recorded 22 distinct dimming events over its 4-year observation period. Dimming depths ranged from 0.5% to an extraordinary 22%. No known planetary body produces dimming exceeding approximately 1%, and Jupiter-sized planets produce roughly 1%. The 22% dip would require an object larger than the star itself if it was solid. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. Bradley Schieffer of Louisiana State University published an analysis in 2016 showing that photographic plates from Harvard's archive, spanning 1890 to 1989, indicated the star had dimmed by approximately 20% over the century, a long-term secular decline far too slow to be explained by a transiting object. This finding significantly expanded the puzzle beyond the Kepler observation period. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation, but the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, Jason Wright of Penn State University co-authored a 2015 paper with Boyajian's team that explicitly discussed the possibility of a Dyson swarm, a collection of orbiting structures built to capture stellar energy, as a potential explanation. The paper noted this was the most exotic explanation and required ruling out natural alternatives first, but the inclusion of the hypothesis in a refereed paper attracted worldwide media attention. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of Boyajian organized a crowdfunded observation campaign through the Las Cumbres Observatory Global Telescope Network, raising over $100,000 from public donors. The campaign successfully captured real-time dimming events in 2017, allowing simultaneous multi-wavelength photometry for the first time and providing data that would prove critical to identifying the cause. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. The SETI Institute conducted targeted radio telescope observations of Tabby's star using the Allen Telescope Array following the 2015 publication. No artificial radio signals were detected at any frequency during observation periods that coincided with dimming events. The absence of detectable radio emissions does not rule out the alien hypothesis, but removed the most easily detectable signature of technological civilization. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations. And in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Tabby's star, the strangest object in the universe, and what it might be. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that Jason Wright and the Penn State team proposed a Dyson swarm, a constellation of artificial collectors in various orbital configurations around the star, as a mechanism consistent with the irregular, non-repeating dimming pattern. No two dips would be identical because different structures would cross the line of sight at different times. The theory was taken seriously briefly, but has been effectively ruled out by subsequent wavelength-dependent photometry, showing the dimmer is not solid. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that Boyajian et al.'s favored explanation involves a cloud of dust and debris, possibly from a recent catastrophic collision between planetary bodies or from a family of exocomets in a disintegrating swarm. Dust particles scatter blue light more than red, producing wavelength-dependent dimming, the signature observed in the 2017 campaign data. A solid structure would block all wavelengths equally. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that Bradley Schieffer's secular dimming hypothesis suggests that an orbiting cloud of dust and debris has been accumulating or redistributing around the star over centuries, producing a long-term dimming trend visible in historical plate records. The mechanism driving the secular change remains debated. A single collision, a migrating disk, or ongoing comet disruption are all candidates. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Tabby's star, the strangest object in the universe, and what it might be does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes Boyajian's 2018 paper in the Astrophysical Journal Letters, based on the Las Cumbres Observatory campaign, confirmed that dimming events are wavelength-dependent, deeper in blue light than in red. This is definitive evidence for a dust-based cause, ruling out any solid, opaque structure. Dust particles of submicron size produce exactly this differential extinction pattern across the optical spectrum. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented. The century-long photographic plate analysis by Schiefer confirmed a genuine secular brightness decline of approximately 20% between 1890 and 1989, validated by subsequent independent plate digitization projects. While some researchers have questioned the plate calibration methodology, the general trend toward long-term dimming has held across multiple analyses. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed SETI at home and the Allen telescope array directed sustained observation at Tabby's star during the 2017 dimming events. No narrowband radio signals, laser pulses, or structured electromagnetic emissions were detected at any frequency above the detection threshold. The star's anomalous behavior is not accompanied by any detectable signature associated with technological activity. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Tabby's star, the strangest object in the universe and what it might be. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Boyajian et al. 2018 wavelength-dependent photometry paper established dust as the cause of the short-term dipping events and effectively closed the alien megastructure debate for most astronomers. The long-term secular dimming documented by Schiefer remains less fully explained and continues to generate active research into disk dynamics and exoplanet populations. SETI targeted observation has found nothing. Tabby's star remains scientifically significant as a laboratory for studying dust dynamics, exoplanet systems, and variable stellar environments. The citizen science model that discovered it has been replicated for other anomalous stars identified in Kepler and test data, establishing a productive new paradigm for large-scale stellar monitoring that continues to generate discoveries. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Tabby's star, the strangest object in the universe, and what it might be from the historical record. Through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Tabby's star ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.